Welcome back, everyone. We're glad you've joined us for another session of MikroTik Canada's online MTCNA tutorials. Today, in episode 29, we will discuss ARP in RouterOS. We'll begin this video by introducing ARP and then explain how it works and how you can use it in MikroTik's RouterOS. To become familiar with ARP, we should first have a look back at something called the OSI model. OSI, or the Open Systems Interconnection Model, is the framework used by computer systems to communicate over a network, consisting of media layers and host layers. As we mentioned when setting up our MTCNA home lab, media layers include the physical layer, the data link layer, and the network layer. Host layers consist of transport, session, presentation, and application layers. With regard to layers 2 and 3, that is the data link and network layers, the former communicates with frames using MAC addresses, while the latter works with packets using IP addresses. Now, in a given IP network, which operates on layer 3, when devices want to communicate, they are required to know each other's MAC or layer 2 addresses. This is where ARP comes into the picture. ARP, that stands for Address Resolution Protocol, is used to discover layer 2 MAC addresses associated with layer 3 IP addresses. It is one of the critical functions of the Internet Protocol Suite, and in IPv6, the functions of ARP are the responsibility of NDP, or Neighbor Discovery Protocol. If you refer to MikroTik's reference on ARP, you'll see the same discussion, that just like DNS, for instance, that translated IP addresses to domain names, ARP is used to create the connection between corresponding layer 2 and layer 3 addresses. You should note that each switch or router has an ARP table which is constantly being updated. This table is usually formed dynamically, but for security purposes, you are able to add static ARP entries as well. Now let's see how ARP actually works on the sample network. Imagine we have a switch with 4 connected IP hosts named A, B, C, and D. On their interfaces, each of these hosts have their specific IP and MAC addresses. Now, when host A wants to communicate with host D via its IP address, it'll first search for host D's MAC address in its own ARP records. In case it comes up short, it will introduce itself to the entire network and ask for the MAC address of its destination IP address, which here is 192.168.0.4. This request will be sent to the entire network as a broadcast request. That is, it has a specific destination IP address, but a broadcast MAC address. The switch receives the broadcast request of host A and relays that message to all IP hosts present on the network. Hosts B and C drop the packet since they are not the intended IP host. However, since host D carries 192.168.0.4, it receives and responds to the request from host A. Host D will announce its MAC address and will reply by giving this information addressed to hosts A IP and MAC address. Now, just as a reminder, if you refer to the interface window of any given hardware and open up one of its interfaces, you'll see that that interface has its own unique MAC address. Therefore, in the case of our sample network, once the network switch receives host D's response, first it will relay that response to host A, then register host D's IP and MAC address on the port to which D is connected, and finally update its own ARP table that will be used to facilitate and expedite traffic flow in the future. Now let's see how ARP works in RouterOS. You can access the ARP window from the IP menu and the ARP submenu. If we open the ARP windows of both the class AP and the trainee router, you will see that the class AP has 2 ARP records and the trainee router currently has 1. The question here is how these records are created. If we refer to the addresses set on the class AP, you'll see that the address 10.0.0.254 is set on the WLAN1 to class interface. By referring to the interfaces window and opening this particular interface, you can see that it comes with a unique MAC address. The MAC address of this interface, as well as the IP address assigned to it, form the ARP record on the trainee router. Vice versa, you can see that the address 10.0.0.1 on the trainee router is assigned to the WLAN 1 to class AP interface. If we open this interface, we can see its unique MAC address as well. Similarly, the MAC address of this wireless interface together with its corresponding IP address create the first ARP record of the class AP. Now, if you're wondering about the second ARP record here, that belongs to the main internet switch present on our home lab network. Now, as previously mentioned, ARP records can be both dynamic and static, with static ARP used for security purposes in order to block out other IP addresses. Here, these ARP records have a DC flag, with D standing for dynamic and C for complete. To make an ARP static, simply open up that ARP record and click on Make Static. Now let's test this static ARP record for the IP address of 10.0.0.1. If we go to the trainee router and change the address of 10.0.0.1 to 10.0.0.2, we'll see that a new dynamic ARP record is created, and if we try to ping the address of 10.0.0.254, we'll see that the ping works fine. Well, why is that? Since we made the ARP record for 10.0.0.1 static, we would expect that a new address would not be able to create a connection with that same MAC address. To answer this question, we should refer to our reference and read about ARP modes that include disabled, enabled, local proxy ARP, and reply only. When set to enabled, as you can see, the interface is free to use ARP without any other conditions. However, if you set the value to reply only, the interface will only reply to ARP requests that have been set statically, and no dynamic entries will be stored in our router's ARP table. Thus, if we go back to the class access point and open up our WLAN 1 to class interface, we can set the ARP mode to reply only. As a result, the ARP record becomes invalid and the ping fails. To resolve this issue, you can go about it in two ways. First, you can open up the static ARP entry and input the new address on the trainee router, that is 10.0.0.2. Once you click apply, you can see that the ping results start flowing in. Alternatively, if you wish to keep your ARP record as it is, you need to change the address on the trainee router back to its previous state, that is 10.0.0.1. Going back to the previous address will also resolve this issue and reconnects the two devices. Bear in mind that when you're creating an ARP record, you require both IP and MAC addresses, and you cannot leave the IP address field empty or choose a MAC address filled with Fs. Moreover, you should take care not to have any duplicates in your ARP tables, because they can result in network dysfunctions and packet loss. And in the end, note that you can also use the ARP via the new terminal utility in Winbox. Here, by inputting the IP command and then the ARP command, you can access the ARP menu. Then, by pressing the Tab button on your keyboard, you can see all the command options available here. By inputting the print command, you can see your ARP records, and from here on out, you can use different commands to add, remove, or edit your ARP records. Thank you very much for watching, everyone. If you like this video, make sure you give us a thumbs up and subscribe to our channel, since we're almost ready to start the next module of this online MTCNA course.